Hello and welcome to this presentation on Omron Sensor Evaluation Board and corresponding sensor components. My name is Carrie Horan and I'm the Product Marketing Manager for Sensors and Modules at Omron. Introducing the Omron Sensor Evaluation Board, released in October of 2019. These sensor evaluation boards support open platform computing systems such as Raspberry Pi, Adafruit Feather, and Arduino. These sensor evaluation boards aid in easy IoT application development and proof of concept. These sensor evaluation boards are equipped with 6 sensing functions and multiple connectors. These boards can connect easily to 14 models of sensors over 4 different sensor types, including thermal sensors, flow sensors, light convergent reflective sensors, and an air quality sensor, all with optional cable harnesses. Sample source codes used to acquire sensor data are published on GitHub and can be modified and implemented independently according to the user's unique application. The sensor evaluation boards will help contribute to the creation of new solutions and better service in sensor testing. Visit our website for more information. This table details the compatibility of each sensor evaluation board with various Omron sensor components. As you can see, the sensor evaluation boards, depending on the model, are able to run with various MEMS and optical type sensor components. There will also be a corresponding harness required, shown in the far right-hand column. This harness is necessary to attach the Omron sensor component with the sensor evaluation board. Each of these products, including the board, each sensor component, and the harness, is sold separately. The next few slides will be a product overview of the various Omron sensor components that can be evaluated using these sensor evaluation boards. The D6T sensor is a non-touch sensor measuring surface temperature of various objects using infrared technology. The sensor is able to measure multiple different data points depending on the module, so it's able to measure the temperature of several different places at once. For example, in the illustration below, we've demonstrated how this would work with the Omron 4-pixel by 4-pixel version. As you can see, the sensor is looking out at a living room scene where 2 children are positioned over to the right-hand side. The sensor gathers this information and outputs raw data through a digital I2C output. In the illustration on the right, we have a grid where the different temperature outputs can be read. As you can see, the surface temperature of the children sitting in the frame output a much higher temperature than the surrounding area. Thus, with the algorithm for human detection, the sensor is able to detect whether or not there is human presence in the scene in front of it. The Omron D6F series is a range of sensors that can detect airflow over a wide range of applications. The sensors are able to detect even the smallest of airflow to our more robust models, which can detect airflow up to 70 liters per minute. As you can see in the picture below, Omron offers a wide range of products, although these products can be divided into 2 main product types. Flow rate sensors connect directly into the tube of an airflow system and measures the total amount of airflow as they pass through the sensor. However, flow velocity sensors are mounted in open air applications, which make it ideal for applications such as HVAC or air controller. These sensors can measure the partial flow or the total flow of air as it passes over the sensor. The sensor can measure changes in the airflow velocity and alert the customer of any changes that may occur due to issues that can arise. These issues range from stoppages or faulty systems. The B5W optical sensor is used for object detection, including the human hand for touchless applications. The sensor is high performance, which means that even in general applications, it's capable of detecting any object, ranging from black opaque to even transparent objects in the case of packaging applications. Moreover, Omron engineers have worked hard to ensure that the sensing stability remains consistent across the range of detectable objects. The performance of this sensor is unaffected by the surface color, material, or reflectiveness of the object. This is shown in the graph in the lower middle part of this slide. Omron is currently continuing to improve these products and release newer versions to continuously improve these specifications. On the left, we demonstrate the basic working principle of this sensor. The LED light and detector project outward and intersect, performing a diamond-shaped sensing area highlighted in purple. Any object that passes through this area will be detected by the sensor. It's worth noting that there is a void space between the sensing area and the sensor itself. This space allows for material to be mounted over the sensor in order to protect it from moisture or residue, as well as allow for a cleaner design if the customer requires it. It's highly recommended to use a clear material, such as glass or plastic, to limit the effect to the sensor capabilities. While it's possible to use a tinted or colored glass, it's not recommended, as this could limit the sensor performance. On the lower right, we see the optical lens technology that has been implemented to this product. Omron engineers have developed the lens and lighting makeup for this sensor to allow for a highly accurate viewing angle, ensuring consistency and accuracy from part to part, so that the customer can remain confident in the sensor's ability even across large volumes. Here we have a short video demonstration of the sensor evaluation board in action.
Hello all, in this video we'll discuss how to use various Omron sensors using Omron's Arduino evaluation board. Step 1. Hardware components. So for this we'll be needing various components which are as follows. Omron's Arduino evaluation board, Arduino MKR microcontroller, thermal sensor, D60 and its harness 01, Omron's differential pressure sensor and its harness 02, Omron's flow sensor and its harness 03, Omron's light conversion sensor and its harness 04, Omron's air quality sensor and its harness 05. Let's move on to step 2, which is hardware setup. First we need to solder the eval board in order to connect it to the Arduino board. So we'll connect eval board to Arduino board like this, and then we'll connect the USB cable to the Arduino board, and then we'll connect the Omron's harness to the Omron's eval board, which would be like this. Keep in mind, pressure sensor and flow sensor use the same connector, so only one of them can be connected at the instance. Step 3. Set up Arduino. Download Arduino IDE from this website. The details for setup is mentioned in the tutorial. Step 4. Setting up the Arduino driver. So run the Arduino IDE on your PC, and then once the IDE is open, connect the Arduino board to your PC via USB cable. After connecting the Arduino board to your PC, if your IDE shows to install the package like you can see on my screen, then you need to install that package. Click on install and then install. So once the package installation is done, you will have to set up the drivers for Arduino board. So click yes and install. So now the installation is completed. Please close it and now go to your device manager. Please see COM port. So as you can see, the COM port in my laptop is COM34. Step 5. Download sample code. Sample code for evaluating sensors is available on GitHub on this link. Click here to download zip file. and you can see here in your downloads folder. Step 6, sample code setup. Go to tools, board, and then select the board type, which is Arduino MKR Wi-Fi 1010. Go to tools and then to port and COM port. Go to sketch, include library, add zip library, and then go to the download folder and open the file. Go to file and then examples, and then the file name was B5W D6F D60, and click on that. So it will open up the code, and the next thing is to do compilation. Click here. Once the code is compiled, please see this message. We need to upload it to the Arduino, so click here. So once the code is uploaded, you will see this message. Step 7, get data. Go to tools, select serial monitor, and then you will see the output window. Step 8, observation. So as you can see, the first output is B5WLB, that is the light convergence sensor. So if you put your finger very close to the sensor, you will see the reading is almost 0. And if I move my finger a little farther, you will see the voltage level increasing. The maximum voltage is around 2 volts. If I go further, it will start to reduce, as you can see. The next one is thermal sensor, that is D6001. Right now the room temperature is around 23 degrees Celsius, but if I move my hand closer to the sensor, you will see the change in the temperature around 26. And if I move hand again, you will see the temperature again as 23. The next sensor is D6FPH, that is the differential pressure sensor. Right now the reading is almost 0. So if I just blow in the sensor, you will see the change in the reading. So one thing you have to note here is that the connector of the differential pressure sensor and the flow sensor is the same. So right now the flow sensor reading is not correct. So I'm going to replace the differential pressure sensor with the flow sensor. Right now the reading of the flow sensor is almost 0. So now I'll blow into the flow sensor. One thing to note here is that I have to blow in the direction of the flow. You will see a change in the flow. And the last one is B5WLD, that is the air quality sensor. Right now you can see the count as 1, and when I bring a cloth closer to the sensor, you will see the count increasing, like 4. And if I move it back, it's 1 again. So these are all the Omron sensors which can be evaluated using Arduino board.
At Omron, we are committed to improving lives and contributing to a better society. We believe not only in the development of sensors in order to provide new technology and support ongoing production of innovative applications, but also utilize this technology to help create a safer and cleaner living space for all. Thank you very much for participating in this presentation on the Omron Sensor Evaluation Board and corresponding components. Again, my name is Kerry Haran, Product Manager for Sensors and Modules at Omron. To learn about these and other components, including other sensors, connectors, power relays, and switches, please visit our website at components.omron.com.